Hello viewers, welcome to this session of aromatic hydrocarbons. We are very familiar with the usual petroleum products. The petroleum products are mainly containing aromatic hydrocarbons. Now, here we will discuss in this session most important aspects of aromatic compounds, and that is nomenclature. We must know how can we name the compound. There should be some systematic name of compounds, and by name of the compound we should identify that this is the aromatic compound and this is this type compound. And also here we will discuss synthesis of benzene from phenol, synthesis of benzene from benzoic acid, synthesis of benzene from acetylene, from benzene diazonium salt and benzene sulfonic acid. The most important point here is the benzene sulfonic acid formation is also industrially very useful. So, here we will see the application of this synthesis in industry and how it is commercially important. So, here commercial importance of desulfonation also we will discuss. So, now let us go to the most important part of this aromatic compound, that is nomenclature of aromatic compound. Perhaps more than any other class of organic compounds, the aromatic substances have acquired a large number of non-systematic names. Therefore, we must also know some of the common names of aromatic compound. The common names of some frequently referred monosubstituted compounds are here. When CH3 group is attached to aromatic ring, we call it as toluene. When OH group is attached to aromatic ring, we call phenol. When NH2 group is attached to the aromatic ring, we call aniline. When CN cyanide group is attached to the aromatic ring, we call it as benzonitrile. Similarly, when there is acetyl group on the aromatic ring, we call it as acetophenone. When isopropyl group is there on the phenyl ring, we call it cumene. When ethene substitution is present on the aromatic ring, we call it as styrene, and you all know about styrene. We use polyvinyl chloride, we use polystyrene. So, that polystyrene is made from this molecule styrene. Styrene is also called vinyl benzene. So, this CH2 double bond CH group is called vinyl group. That is why this is vinyl benzene. And this, when aldehyde group is there on the aromatic ring, we call it as benzaldehyde. Similarly, when COOH is there, we call it as benzoic acid. When CH2 group is on the aromatic ring, we call it as benzyl, BENZYL. And when it is present as alcohol OH, then we call this compound as benzyl alcohol. When ether group is present on aromatic ring, for example OCH3, then this is called anisole. And when ethoxy group is present on aromatic ring, we call it as phenitol. So, these are some very common names which are generally used. However, benzene derivative are systematically named with benzene as a parent name. For example, you see, if there is halogen atom on the aromatic ring, we call it as halobenzene. For example, fluorine is there, fluorobenzene, chlorine is there, chlorobenzene, bromine is there, we call it as bromobenzene, iodine is there, we call it as iodobenzene. And if nitro group is there on the benzene ring, we call it as nitrobenzene. Similarly, when alkyl chain is present, for example, you see 3 carbon chain, 3 carbon we know propane, and this is attached to the first carbon, we call it as normal propyl. So, this is also called N-propyl benzene. And if benzene is attached to the second carbon of the propane, we call it as isopropyl benzene. And if benzene is attached to the tertiary butyl group, we call it as tertiary butyl benzene. So, thus the monosubstituted compounds are named in a non-systematic way. Now, the common names of some disubstituted benzene derivatives are also preferred, and we use these prefixes like ortho, meta, para with respect to a particular reactive group, in which the ortho refers to the second position, meta refers to the third position, and para refers to the fourth position with respect to the reactive group. For example, you see, according to IUPAC nomenclature, these prefixes ortho, meta, para are not used, but we use the number, and we show the position of the substitution by the number. The carbon of aromatic ring that is attached to the most reactive functional group is given the one number, and the IUPAC rule of numbering is followed. For example, you see here, if benzene has 3 methyl group, and if this group methyl groups are adjacent, we call it as orthoxylene. When the methyl group are far apart, right, at third position, we call it as metaxylene. And when methyl group is, both the methyl group are exactly opposite at fourth position with respect to one group, we call it as paraxylene. So, orthoxylene is nothing but 1,2-dimethyl benzene, metaxylene is 1,3-dimethyl benzene, paraxylene is 1,4-dimethyl benzene. Similarly, if we have 2 bromine atoms on the benzene ring, we call it as ortho-dibromobenzene, this we call it as meta-dibromobenzene, this we call it para-dibromobenzene. So, IUPAC name of para-dibromobenzene will be 1,4-dibromobenzene. Meta-dibromobenzene will have IUPAC name 1,3-dibromobenzene, and ortho will be 1,2-dibromobenzene. Thus, adjacent 1,2 position is ortho, 1,3 position is meta, 1,4 position is para. Similarly, when we have 2 different functional group, like one is, see here, NH2 and one is CH3, this compound is called toluidine, and since NH2 group is ortho to CH3, we call it as orthotoluidine. In this compound, NH2 group NH2 group is as third position, we call it as metatoluidine, and here NH2 group is at fourth position, we call it as paratoluidine. And IUPAC name, as you know, this is 2-aminotoluene, this is 3-aminotoluene, this is 4-aminotoluene. If a long alkyl chain of more than 2 carbon is attached to the benzene ring, then here benzene ring is considered as phenyl substituent, but the alkyl chain is considered as the parent chain. So, here we use a prefix phenyl for the benzene ring. For example, you see here there are 2 carbon on benzene ring, we call it as ethyl benzene. But when there are 3 carbon of benzene ring, then here we consider this 3 carbon chain as parent chain, and this benzene ring we take as phenyl substituent. And you see the position of this long chain, alkyl chain. So, according to the IUPAC rule, the one number should be given to this carbon. So, phenyl substituent is present at one number, therefore, this is called 1-phenyl propane. Similarly, 3 carbon chain, if benzene is attached at the second position, then here we give the numbering from either side 1, 2, 3, 1, 2, 3. So, at 2 position there is phenyl ring benzene. So, here we will name this as 2-phenyl propane. Remember, this is cumene, and see this one having 4 carbon long chain. Here benzene is attached at second position. We should start numbering from here 1, 2, 3 according to IUPAC rule. So, this compound is now 2-phenyl butane. That is how long alkene chain containing aromatic compounds are named. Now, when there is active group like double bond, triple bond, etc., then also the alkene chain we consider as parent chain, even it has 2 carbon. See this one, this we know very well, this is a styrene. So, styrene is what? Here there are 2 carbon having double bond. So, alkene group is a functional group. So, here we number this as 1 and 2. So we consider as functional group as ethene. So this compound is named as phenylethene. And here there are 3 carbon with double bond, and phenyl nucleus is at one position here. So we call it as 1 phenyl propene. Similarly, 4 carbon containing alkene group, when phenyl is benzene is a substituent. So here we give the numbering as per IUPAC rule from here 1, 2, 3, 4. So this phenyl group is at 2 position. So we call it as 2 phenyl butene. 4 carbon long chain is the butane and double bond is alkene. That's why we give, and position of double bond is at second. So we give name butene. So name of this compound is now 2 phenyl butene. Similarly, when we have 4th carbon chain is alkyne group, then according to IUPAC rule, we start the numbering from the functional group carbon. So we will number this as 1. So 1, 2, 3, 4. There are 4 carbon alkene chain on benzene ring. So then benzene ring is attached at the 4th carbon. So we will take now this benzene ring as a substituent phenyl. So name of this compound will be 4 phenyl but1-ine. So thus, if long alkene chain is there, the numbering is done on the parent alkene chain, and phenyl benzene ring is taken as phenyl substituent. If phenyl ring is further substituted along with long alkene chain, then how should we name? Then here the position and names of the substituent of the phenyl ring are written in the brackets, and phenyl is attached to the long alkyl chain. So where is it attached, that position we should write. So we will here also consider the parent chain as a long alkene chain and phenyl as a substituent. Now let us see how this happens. See here there are 3 carbon on the benzene ring. So this is a phenyl substituent, but now here there is also another group, methoxy group. So this phenyl ring is now substituted. So how to name it? So here what we do is, here what we consider, the phenyl carbon attached to the long alkyl chain is given the number 1. So here this phenyl group is attached to this long alkene chain. So this carbon we will give number 1. So now we start the numbering to the phenyl ring. So this is 1, this is 2, this is 3, and this is 4. So at 4 position of phenyl ring there is methoxy group. Hence now we will write this name of phenyl nucleus in bracket, and parent chain will be our 3 carbon chain alkene chain. So here we will see the IUPAC numbering. So number 1 will be here. So this phenyl is attached at number 1. So now the name of this compound will be 1 dash in bracket 4 methoxy, because this is methoxy substituent and it is at 4th position in the phenyl ring. So we will write in bracket 4 methoxy phenyl and then long alkene chain propene. So name of this compound will be 1 dash bracket 4 dash methoxyphenyl bracket over propene. Similarly, you look at this compound. Here there are 4 carbon alkene chain. So our main compound is butane. Since there is double bond, this will be the butene. So word root is our butene. Now here phenyl is attached at 2 position, but there is bromine substituent. And now what we will do, this carbon we will take as number 1, this is number 2, this is number 3. So at 3 number bromine is there. So we will give this as 3-bromophenyl substituent. Now this is attached at the 2nd position of this long alkene chain. So name of this will be now 2 dash in bracket 3-bromophenyl but2-ene. So is it clear? So here you see this double bond is at 2 position, that's why but2-ene. Bromine is at 3 position of phenyl and it is substituent on the phenyl, that's why we write in the bracket. So this will be 3-bromophenyl, and this 2nd position is the long alkene chain where it is attached. So our compound is now 2 dash bracket 3 dash bromophenyl but2-ene. Similarly here Here you see there is 4 carbon long alkyl chain. So, that is our parent chain, and according to IUPAC name we will give the functional carbon as number 1. So, this will be number 1, 2, 3, 4. So, at 4 carbon this phenyl is there. Now, this phenyl has 2 substituents, right? 1 nitro here, 1 nitro here. So, now we will start numbering only from this long chain where it is attached to the phenyl ring. So, this phenyl carbon will be number 1. So, 2. So, there is nitro group at 2 position. We will go ahead 3, 4. There is also nitro group at 4 position. So, nitro group is at 2 positions, 2 and at 4 position. So, 2 nitro group are there. We will write as 2,4 dinitro, and this is phenyl. So, it becomes now 2,4 dinitrophenyl, and this is attached to the 4th carbon of long alkene chain, which is butane. So, our compound will be now 4 dash in bracket 2,4 dinitrophenyl but 1 ine. So, this is how we name the phenyl substituted long alkene chain aromatic compound. So, I hope you have understood well naming of aromatic compound. Now, let us go to preparation of benzene. First preparation we will take from acetylene. When vapors of acetylene is passed through very red hot tube, the 3 moles of acetylene molecule undergo addition reaction to form highly stable aromatic system, that is benzene nucleus. So, this is the first preparation from acetylene. When this reaction occurs, there occurs additions of 3 moles of acetylene molecule. Now, next reaction we will see is from phenol. Phenol can also be converted into the benzene when it is treated with zinc metal. When phenol is heated with the zinc metal dust, there is formation of benzene and zinc oxide. Thus, the phenol undergoes reduction to the benzene molecule and oxygen gets converted into very stable inorganic compound oxides of zinc 2. Thus, on treatment of phenol with the zinc dust, we get benzene. Then third preparation we take from benzoic acid. This is very important process, since this has found application in our regular laboratory practicals also. We do the soda lime test. That soda lime test is related to this preparation of benzene. Actually, what happens when benzoic acid is strongly heated with dry soda lime, it undergoes decarboxylation and forms benzene. Benzene can also be prepared by electrolysis of sodium salt of benzoic acid. The sodium salt of benzoic acid also results in the decarboxylation, and in this process of preparation of benzene, carbon dioxide is eliminated from the benzoic acid molecule. This is referred to as decarboxylation of carboxylic acid. So, here you see when we heat the benzene with soda lime, then benzoic acid is converted into benzene. Similarly, when sodium salt of benzoic acid, sodium benzoate, is subjected to the electrolysis, then that also loses the carbon dioxide and gets converted into benzene. So, we can prepare benzene from benzoic acid by heating with soda lime and by electrolysis. From benzene diazonium salt, when benzene diazonium chloride is treated with hypophosphorus acid in presence of catalyst copper 2 plus salt, we get benzene. Benzene can also be prepared from benzene diazonium chloride when it is reduced with stannous chloride in alkaline medium, and when benzene diazonium chloride is treated with absolute ethanol, there is removal of nitrogen and we get benzene. So, we can prepare benzene from benzene diazonium chloride by these 3 methods. Next most important procedure of preparation of benzene, from benzene sulfonic acid. When benzene sulfonic acid is steam distilled over 150 degree centigrade temperature, there is formation of benzene and sulfonic group is eliminated. So, we call it as desulfonation of benzene sulfonic acid. Similarly, by heating at about 200 degrees centigrade with dilute hot HCl, we can convert benzene sulfonic acid into benzene. So, here most important advantage of that, the benzene sulfonic acid undergoes desulfonation when it is treated with hot dilute HCl at about 150 to 200 degrees centigrade under the pressure. Let us see importance of this desulfonation reaction. How this is important? This is very important reaction for industries. For example, see, you are already familiar about sulfonation of benzene. Sulfonation of benzene gives benzene sulfonic acid, but this reaction is readily reversible. Sulfonation of benzene is favored in strong sulfuric acid, while desulfonation is favored in hot dilute aqueous acid. So, when you treat benzene sulfonic acid with hot dilute acid, desulfonation occurs, and this desulfonation is very useful preparation for certain isomer. Let us see important example. For example, if we want to prepare orthochlorotoluene, now there is one method, Friedel-Crafts halogenation. When we do Friedel-Crafts halogenation of the toluene, we get two isomer, parachlorotoluene and orthochlorotoluene. But parachlorotoluene is a major product. So, our desired compound orthochlorotoluene we do not get, but that orthochlorotoluene we can prepare using desulfonation reaction. See how. First of all, we do the sulfonation of toluene. So, sulfonation of toluene gives paratoluene sulfonic acid in major amount. This paratoluene sulfonic acid is then halogenated with the chlorine and in presence of FeCl3. So, we get here orthochloro derivative of paratoluene chlorosulfonic acid. Now, as desulfonation occurs when sulfonic acids are heated with hot dilute acid. So, here this orthochlorotoluene sulfonic acid when heated with dilute HCl above 150 degrees centigrade, it undergoes desulfonation and it forms 100% orthochlorotoluene. So, we can get only one isomer orthochlorotoluene from toluene, which we do not get by directly chlorination. Thus, this reaction desulfonation is very useful to prepare orthochlorotoluene. Second most important is, this is industrially very important reaction. We are very much familiar with the polyester fibers. Polyester fibers are prepared from terphthallic acid, and terphthallic acid is prepared from the xylene. And how do we get this xylene? Xylene is a petroleum product, but when we distill the petroleum, we get the xylene fraction, but here we get 3 isomers of xylene, and terphthallic acid is made from the only one isomer, para isomer. So, how to separate para-xylene from the mixture? That we can do by desulfonation reaction. See, desulfonation may also be used to separate certain isomer. For example, xylene fraction from coal tar may be treated with cold 80% sulfuric acid. Now, in this cold 80% sulfuric acid, only meta isomer, meta-xylene reacts, whereas ortho and para do not react, and this meta-xylene dissolves in the cold sulfuric acid. So, when we separate the cold sulfuric acid and remaining residue, then meta-xylene is separated from the mixture of ortho and para, and then we can carry out meta-xylene isomer, right, in this way. See here, meta-xylene in cold 80% sulfuric acid forms sulfonic acid, whereas in this condition para-xylene or ortho-xylene do not form. So, we separate the H2SO4 in cold condition, and there we recover meta-xylene sulfonic acid, and this meta-xylene sulfonic acid when heated with dilute HCl at about 150 degree, desulfonation occurs and we get only pure metaxylene. Now what we do? Here we are left with the mixture of para and orthoxylene. This para and orthoxylene reacts with concentrated sulfuric acid and orthoxylene forms orthoxylene 4-sulfonic acid, paraxylene forms paraxylene 2-sulfonic acid. Both isomers are different and hence both have different melting boiling point. Hence this sulfonic acid derivative of orthoxylene and paraxylene can be separated by fractional distillation. So what we do in this reaction, mixture of ortho and paraxylene we treat with concentrated H2SO4. So orthoxylene is converted into orthoxylene 4-sulfonic acid, see here at position 1, 2, 3, 4, and paraxylene gives sulfonic acid, and here we see the position 1, 2. So paraxylene 2-sulfonic acid. Both have different melting point and they can be separated by fractional distillation. So we separate these two molecules. Para isomers is less soluble, so it crystallizes first, we separate it and then we recover ortho isomer. Now this ortho sulfonic acid isomer and parasulfonic isomer are treated with hot dilute acid HCl at about 150 degree. So desulfonation occurs. So orthoxylene with 4-sulfonic acid undergoes desulfonation and gives only orthoxylene, and para isomer which we have separated as paraxylene 2-sulfonic acid, that is treated separately with HCl at about 150 degree and it gives only para isomer. Thus all the three isomers ortho, para and metaxylene can be separated by using desulfonation method. So benzene desulfonation is very important method as far as this industrial preparations are concerned. Will you believe it or not, about 5 million per year, 5 million tons per year of paraxylene is used to prepare polyester. Now let us summarize what we have discussed in this session. We have discussed here very important point of our organic chemistry, which is including nomenclature of aromatic compound. Second thing, we had discussed synthesis of benzene from phenol, benzoic acid, acetylene with from diazoleum salt and benzene sulfonic acid. And the most important process here is conversion of benzene from benzoin sulfonic acid is the desulfonation, and this desulfonation reaction is commercially very important because it is used for separation of isomers which are commercially very important. So we had seen the commercial importance of desulfonation of benzene, preparation of alkyl benzene using Friedel-Crafts alkylation, and we also discussed some of the limitation of Friedel-Crafts alkylation, and then we discussed Friedel-Crafts acylation with its mechanism and how this Friedel-Crafts acylation is useful in preparing and substituted alkyl chain on the benzene ring. Then we discussed application of this Friedel-Crafts reaction with example where we have found formation of N-propyl benzene as well as N-butyl benzene. So normal alkyl chain can be prepared from aromatic compound. Then we have discussed very important point, side chain oxidation of alkyl benzene, and in this reaction we have seen that side chain oxidation can be carried out by oxidizing agent, and also side chain oxidation can be carried out via halogenation and hydrolysis. So I hope you have gone through all these topics very well and you have understood. Thank you very much.